This is the second video in a series of videos on the normal distribution, and we're going to look at a specific type of problem, and let's look at it. Let's say that we have a distribution with a given mean. Let's say we have a distribution of a mean of 40 and a standard deviation of 6. And we want to find the probability that x is greater than 37. Now, the steps to do this is the very first step that we want to do is we want to calculate a z-score. And if you still have trouble with that, then you can look at a video on how to calculate a z-score. And the way that we want to calculate a z-score is the z-score, so this is step 1. The z-score will be xi minus mu over sigma. So in this case it will be 37 minus 40 over 6. Or in this case, let's see, 37 minus 40, that's minus 3 over 6. Or minus 1/2. Let's put that in a decimal, minus 0.5. And that's our z-score. And in general, z-score will be some kind of decimal, but that's okay, there's nothing wrong with decimals. The second step is we're going to use a normal table. Now, normal tables are all a little bit different, but basically the idea of a normal table is it provides you with the relationship between probabilities and z-scores. So let's look particularly at the normal table that we have. It's pretty common. And here what we do is the normal table here is we have z-scores along this row and along this row. And the numbers in here represent this probability, right? The probability that you're less than some value. So let this be z, your z-score, and you're always going to find the probability that x is less than or equal to some z-score. Now, you might want to find out what it is between two values, and then you just use this table to adjust it. But in this case, your z-score is minus 0.5, so I like to go ahead and draw this out. So there's this mean is always going to be 0, the mean of the standardized score. So this is minus 0.5, so it's half standard deviation away. And you're going to find, in this case, the probability from the table, the probability that your z-score is less than minus 0.5. And that equates to the probability that x is less than or equal to 37. Because the z-score of 37 in this case is 0.5. Now you look this up on a table, and the way you look on this table is you just go down the row until you get 0.5, minus 0.5, and read across, and you get 30.3085. 0.3085. Which means the probability that x is less than 37 is the same thing, 0.3085, or 30.85%. Now you have to think about that, whether or not that's what we want or not. What we want originally, our actual question here, is the probability that x is greater than 37. So if the probability that's less or equal to 37 is 30.85%, that means the probability that it's greater than or equal to 37 is 1 minus that. So it's 1 minus 0.3085, or another way to say that is 0.6915, or 69.15%. And that's how you use the standard normal table. Now, the way that standard normal tables are usually done is there's a z-score here. In this case, it starts out with minus 3.4, minus 3.3. We go all the way to minus 0.5. And then as you read across, you have 0.00, 0.01, 0.02, etc. We have 0.500, so that's that figure right there, and that's where we get the number 0.3085. Let's say you had a z-score of minus 3.32. So that would be minus 3.3 minus 3.2. You just read down, and then you go across. Minus 3.32 would be, this is 3.3, and this is 0.2, so it's down right there. Minus 3.32, and that's that number right there. Check on your own to make sure we get the right answer. Minus 3.32 is 0.0005. 0.0005. And that's how you use standard normal tables. Let's do one more example. Let's find the probability that x is going to be less than, let's say, 12 when mu is equal to 15 and sigma is equal to 9. So first step is you calculate the z-score. The z-score is x minus mu over sigma. In this case it is 12 minus 15 over 9, or minus 3 over 9, or minus 1/3. Let's put that in the calculator. From the calculator you get minus 0.33 repeating. And now I like to draw this out. Sometimes what people like to do is draw two of these, one with the actual value and one with the z value. The actual value here is the mean is 15, and you want to find out the probability that's less than 12. When you put those in z-scores, the standardized score of the mean is 0, so then that's minus 0.33. And here we're finding the probability is less than, so we're finding this area here. So you look at your z-table. Z-table, you go down here, that starts out at minus 3.4. You go all the way down until it's minus 0.3. And then you come across to 0.00, 0.1, 0.2, 0.3. And right there is minus 0.33, right? Go to minus 0.3, minus 3, and come down. Let's look at that. Look, you look at yours and I'll look at mine, and you get 0.3707. 0.3707. So in other words, the probability of falling less than will be 0.3707. Now let's think about if that's what we want. Do we want less than that value? Yeah, we want the probability of less than 12, so that's your answer right there, 0.3707, or 37%. And that's how you do z-tables. In the next video, we'll look at how to do z-tables when you want to find between two numbers.